Hello viewers, welcome back to our channel Career Prep. Today we'll learn all about the properties of HCF and LCM. Being thorough with the formulae in this video will help you in solving questions on HCF and LCM faster. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. Now let's learn about the properties of HC and LCM one by one. Property 1. The product of LCM and HCF of any two given natural numbers is equal to the product of the given numbers. This means the LCM of two numbers multiplied by HCF of the two numbers is equal to product of the two numbers. Supposing the two given numbers are A and B, then the HCF and LCM formula states that A multiplied by B is equal to HCF of A and B multiplied by LCM of A and B. Now, using this formula, we can calculate HCF or LCM of any two numbers if we know the two numbers and if we know either the HCF or the LCM. This means that if we know the two numbers and the LCM of the two numbers, then we can find the HCF of the two numbers. HCF of two numbers is equal to product of the two numbers divided by LCM of the two numbers. Supposing we know the two numbers and the HCF of the two numbers, then we can find the LCM of the two numbers. LCM of the two numbers is equal to product of the two numbers divided by HCF of the two numbers. Now you have to remember these three formulae which will help you in solving problems on HCF and LCM. LCM of two numbers multiplied by HCF of the two numbers is equal to product of the two numbers. HCF of the two numbers is equal to product of the two numbers divided by LCM of the two numbers. LCM of the two numbers is equal to product of the two numbers divided by HCF of the two numbers. Understand that this property is applicable only if there are two numbers. It's applicable for only two numbers. Now let's understand all this with an example. Prove that LCM of 6 and 18 multiplied by HCF of 6 and 18 is equal to product of 6 and 18. Now we know that the two numbers are 6 and 18. So first let's find the LCM and HCF of 6 and 18. We'll do this by the prime factorization method. So 6 can be written as 2 multiplied by 3. 18 can be written as 2 multiplied by 3 multiplied by 3. Now HCF of 6 and 18 is equal to 2 multiplied by 3 multiplied by 3, which is 18. So LCM of 6 and 18 is 18. Now HCF of 6 and 18 is 2 multiplied by 3, which is 6. So HCF of 6 and 18 is 6. Now we know that LCM of 6 and 18 is 18 and HCF of 6 and 18 is 6. Now LCM of 6 and 18 multiplied by HCF of 6 and 18 is equal to 18 multiplied by 6, which is 108. Now the two numbers are 6 and 18. So product of the two numbers is product of 6 and 18, which is 6 multiplied by 18, which is 108. So now we found that LCM of the two numbers multiplied by HCF of the two numbers 6 and 18 is 108, and product of the two numbers 6 and 18 is also 108. So LCM of 6 and 18 multiplied by HCF of 6 and 18 is equal to 108, which is also the product of 6 and 18. Property 2. HCF of coprime numbers is 1. Let's see if this is correct. by taking two co-prime numbers 21 and 22. First, we have to find the HCF of 21 and 22. We'll find the HCF of the two numbers by prime factorization method. To do that, first we have to find the factors of 21 and then find the factors of 22 separately. To find the prime factors of 21, divide 21 by 3, you will get 7. Divide 7 by 7, you will get 1. So 21 can be written as the product of its prime factors. So 21 is equal to 3 multiplied by 7 multiplied by 1. Now to get the prime factors of 22, first divide 22 by 2, you will get 11. Divide 11 by 11, you will get 1. Now 22 can be written as the product of its prime factors. So 22 is equal to 2 multiplied by 11 multiplied by 1. When you notice these factors, you'll see that 1 is the highest common factor here. So HCF of 21 and 22 is 1. That is, HCF of co-prime numbers is 1. Property 3. We know that HCF of co-prime numbers is 1. Now, HCF of two numbers multiplied by LCM of two numbers is equal to the product of the two numbers. So, if HCF is 1, then LCM of the given co-prime numbers is equal to the product of the numbers. This means that LCM of co-prime numbers is equal to product of the numbers. Let's check whether this is correct using the two co-prime numbers 21 and 22. First, we have to find the LCM of 21 and 22. We'll find the LCM of 21 and 22 by division method. So, first write 21 and 22 in the same row. Then divide these numbers by 2. 21 cannot be divided by 2 completely. So write 21 as it is in the next row. 22 divided by 2 is 11. Write 11 in the next row. Next, divide by 3. 21 divided by 3 is 7. So write 7 in the next row. 11 cannot be divided by 3 completely. So write 11 as it is in the next row. Next, divide by 7. 7 divided by 7 is 1. Write 1 in the next row. 11 cannot be divided by 7 completely. So write 11 as it is in the next row. Next, divide by 11. Write 1 as it is in the next row. Dividing 11 by 11, you get 1. Write 1 in the next row. So finally, you get the prime factors 2, 3, 7, 11 and 1. So LCM of 21 and 22 is equal to 2 multiplied by 3 multiplied by 7 multiplied by 11, which is 462. Now the product of 21 and 22 is also 462. Thus you found out that LCM of 21 and 22 is equal to the product of 21 and 22. That is, LCM of co-prime numbers is equal to product of the two numbers. Now let's learn about HCF and LCM of fractions. This is property 4. We can find the LCM of fractions by using this formula. LCM of fractions is equal to LCM of numerators divided by HCF of denominators. You can find the HCF of fractions using this formula. HCF of fractions is equal to HCF of numerators divided by LCM of denominators. Memorize these two formulae to find the HCF and LCM of fractions. Let's understand this with examples. Let's take the two fractions 4 by 9 and 6 by 21. Here 4 and 6 are the numerators of the fraction. 9 and 21 are the denominators of the fractions. First, find the LCM and HCF of the numerators. Then find the HCF and LCM of the denominators by any of the three methods, either by the common factor, listing out the common factors, or by prime factorization method, or by division method. When you do that, you'll see that the LCM of the numerators 4 and 6 is 12. HCF of the numerators 4 and 6 is 2. LCM of the denominators 9 and 21 is 63. HCF of the denominators 9 and 21 is 3. Now, as per the formula, we can find the LCM of the two fractions 4 by 9 and 6 by 21 if we know the LCM of the numerators and HCF of the denominators. So here LCM of numerators is 12 and HCF of the denominators is 3. So LCM of the given two fractions is equal to LCM of the numerators divided by HCF of the denominators, which is nothing but 12 divided by 3, which is 4. Now we can find the HCF of the given two fractions if we know the HCF of the numerators and the LCM of the denominators. So HCF of 4 by 9 and 6 by 21 is equal to HCF of numerators divided by LCM of denominators, which is nothing but 2 divided by 63, because we have found out that the HCF of numerators is 2 and and LCM of the denominators is 63. So HCF of numerators divided by LCM of denominators is nothing but 2 by 63. Property 5. The HCF of given numbers is never greater than any of the numbers. Let's check if this is correct by considering two numbers 16 and 22. First, let's find the HCF of 16 and 22 by prime factorization method. So, let's find the prime factors of 16 first. Divide 16 by 2, you will get 8. Divide 8 by 2, you will get 4. Divide 4 by 2, you will get 2. Divide 2 by 2, you will get 1. So the prime factors of 16 are 2, 2, 2, 2 and 1. Now 16 can be written as the product of its prime factors, as 16 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2. Now let's find the prime factors for 22. 22 divided by 2 is 11. 11 divided by 11 is 1. So the prime factors of 22 are 2, 11 and 1. Now 22 can be written as the product of its prime factors as 22 is equal to 2 multiplied by 11. Now when you look at all these factors, you'll notice that 2 is the common factor here. So HCF of 16 and 22 is 2. Thus, 2 is not greater than 16, 2 is not greater than 22. Thus, HCF of the given numbers is never greater than any of the numbers. The HCF can be equal to the numbers or less than the numbers, but HCF is never greater than the numbers. Property 6. The LCM of given numbers is never less than any of the numbers. Let's check if this is true by considering two numbers 16 and 22. First, let's find the LCM of 16 and 22 by division method. So write 16 and 22 in one row. Divide by 2 first. 16 divided by 2 is 8. 22 divided by 2 is 11. So write 8 and 11 in the next row. Divide again by 2. 8 divided by 2 is 4. Write 4 in the next row. 11 cannot be divided by 2 completely. So write 11 as it is in the next row. Divide again by 2. 4 divided by 2 is 2. Write 2 in the next row. 11. Write 11 as it is in the next row. Divide again by 2. 2 divided by 2 is 1. Write 1 in the next row. Write 11 as it is in the next row. Now divide by 11. Write 1 as it is in the next row. 11 divided by 11 is 1. Write 1 in the next row. So the prime factors of 16 and 22 are 2, 2, 2, 2 and 11. So LCM of 16 and 22 is 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 11, which is 176. Now you can see that 176 is not less than 16 and 176 is not less than 22. Thus 176 is not lesser than the numbers 16 or 22. Thus, LCM of the given numbers is never less than any of the numbers. It can be equal to the numbers or greater than the numbers, but never lesser than the numbers. Property 7. If a number say x is a factor of another number say y, then the HCF of x and y is x and the LCM of x and y is y. Let's check if this is true by considering two numbers 4 and 16. When you look at these two numbers, you'll notice that 4 is a factor of 16. Now, first we have to find the HCF and LCM of 4 and 16. We'll do this by prime factorization method. So 4 can be written as 2 multiplied by 2. 16 can be written as 2 multiplied by 2 multiplied by 2 multiplied by 2. Now when you look at these factors, you'll see that the HCF of 4 and 16 is 2 multiplied by 2, which is 4. And LCM of 4 and 16 is 2 multiplied by 2 multiplied by 2 multiplied by 2, which is 16. Now we have found out that the HCF of 4 and 16 is 4 and LCM of 4 and 16 is 16. Thus, among the two numbers 4 and 16, since 4 is a factor of 16, the HCF of 4 and 16 is 4 and LCM of 4 and 16 is 16. Property 8. The HCF of given numbers is always a factor of their LCM. Let's check whether this is true by taking two numbers 4 and 16. First, we have to find the HCF and LCM of 4 and 16. We'll do this by prime factorization method. So 4 can be written as 2 multiplied by 2. 16 can be written as 2 multiplied by 2 multiplied by 2 multiplied by 2. When you look at these factors, you will see that the HCF of 4 and 16 is 2 multiplied by 2, which is 4. The LCM of 4 and 16 is 2 multiplied by 2 multiplied by 2 multiplied by 2, which is 16. So HCF of 4 and 16 is 4 and LCM of 4 and 16 is 16. Clearly, you can see that 4 is a factor of 16. So the HCF of the given numbers is always a factor of their LCM. Viewers, please go through this video till you are perfect with the concept. We have a video which will help you to learn a few formulae useful for solving problems related to HCF and LCM. Please do watch that video. If you have liked this video, please like, subscribe and share this video. Thank you.